Hello students, today we are going to discuss very interesting topic of operations research, that is queuing theory. The topic is important from the point of view of university exam as well as competitive exams. So before starting the queuing theory, let's first discuss what is queue. Being a mechanical engineer, is it required to study queue? The answer is very interesting. Queue is a part of our life. Take example, at railway reservation window. Railway reservation counter. You will find a long queue. In other sense, we are used to say a line. There is a huge line of customers. That is known as a queue. So at railway reservation window, if you are going to reserve your ticket, you will find the queue. Even at bank counter, you will find a queue. It is not limited to bank counter or at ATM, even at food court or mess in hostel. You have to wait for a service, that is queue. So we can say that queue is formed because customer has to wait for his service. Customer's turn is not arrived and therefore customer has to wait, and because of that queue is formed. This phenomenon is not limited to human being. We have discussed here is about human being. But let's take example goods at workshop. You can say it is work in process goods at workshop waiting for further machining operations or any other operations. It's a in queue. Take another example, that number of calls at telephone exchange. Even in today's digital era, when we are calling to customer care, many times we have to wait for our turn. So it is not limited to human being, but goods. Take another example, goods waiting for dispatch at warehouse, or you can say luggage waiting at operator for his owner. So there are so many types of queue. In fact, we can say that waiting is a part of our life. To become a part of queue is a part of our life. So it is very important to study the queue. Is the queue desirable? No. We are used to be a part of queue, but it is never desirable, because queue, when you are in a queue, it is killing your time. You are idle. It is wastage of time. So queue is never desirable. Another thing, when you are in queue, customer is dissatisfied from the service. Many times it happens that if you have a multiple option, you will choose the option where there is a minimum queue, where there is a minimum waiting time. So customer in the queue is the dissatisfied customer, and it creates bad image of service provider. So queue is not desirable. Now let's see the mathematical model of queue, and before that discussing, we will discuss various components of queue and customers behavior. Let's take a case. There is one server. He is providing a service to a customer. So you can see these are the customers. Here is the server. and outgoing there is a customer, happy customer receiving the service, happy customer with receiving the service. So server is providing a service to the customer. Say it's a bank counter. For an example, let's take it as a bank counter where cashier is providing a service to the customers. Now see how queue build up. Why queue build up? For that, let's consider two parameters. One is service rate. It's a rate at which server is providing a service to the customer. Say for this case it is a 10 minutes per customer. Okay. Another parameter is customer arrival rate. Customer arrival rate. Say it is a 5 minutes. So at each 5 minutes a customer is coming. Service rate is 10 minutes per customer. So what happens? When a server is providing a service to customer 1, it takes 10 minutes to serve him. Another 2 customers already arrived, and therefore queue build up. So remember, whenever service rate is higher than customer arrival rate, queue forms. Whenever service rate is higher than customer arrival rate, so it is definite that queue forms. But when service rate is higher than the customer arrival rate, say for example 5 minutes per customer and the customer arrival rate is 10 minutes. So what happened? A customer came to the server gave him a service within a 5 minutes. He completed the server, customer is happy and exit the queue, and for next 5 minutes there is no other customer and server is idle. There is no waiting time. So there is no queue, but server is idle. Server utilization is less. So whenever service rate of providing the service is higher than the rate of customer arrival, queue forms. But when the service is very quick and it is less than the customer rate of arrival, there is no queue. But in such scenario, server remain idle and it is a lower utilization of the server. So in queuing problem, our focus is on 2 points. One is customer minimization of customer waiting time, and second is maximization of server utilization. So here in queuing problem we focus on minimization of customer waiting time and maximization of server utilization. By creating a multiple counter, we can eliminate the customer waiting time. In fact, there is a zero customer waiting time. But on other hand, server remain idle, and because of that there is a poor utilization of facility. It reduces the profit of the company and overall reduce the bottom line of the company. So it is not desirable. So there is a negotiation between customer waiting time and server utilization. So now we will discuss customer behavior. So first customer behavior is bulk arrival. Bulk arrival means customer are come for the service in a bulk. Say in case of traffic signal, when the traffic signal release, all traffic cross the road in a bulk. The traffic release in a bulk. Say at the exit of cinema group, when you watch the movie, you complete the movie, and at exit door, everyone go outside in a bulk. So such kind of arrival is known as the bulk arrival. It is in general the arrival is always one by one, but in special cases it's a bulk arrival. Let's take another case, another customer behavior, that is known as the joking. So in joking, what happens? There are more than one server, like in a petrol pump. When you go to fill the petrol or diesel at petrol station, there are so many different pumps available for your choice, and the queue length is different in each petrol pump. So let's take example. There are 3 different counters and 3 different queue. So a customer came to the system. It is known as a queuing system. Say a customer came to the system. He joined the system. Then he observed that the queue length is small in counter number 3. The queue length is small in counter number 3, and he jumped into the queue. So from counter number 1, he jumped to counter number 3. Such behavior of customer is known as joking. Customer came to the system, joined the queue, then he sees that there is a smaller queue in other counter, and in anticipation of lower waiting time, he jumped from one queue to another queue. Such behavior is known as joking. Clear? Now let's discuss another behavior. Another is known as barking. Let's write down here. Barking. In this behavior, what happened? Customer came to the system. Say customer came to the system. He sees that there is a customers already waiting in the queue, and without receiving the service, without joining the queue, the customer left and he do not join the queue. So such behavior of the customer is known as a barking. Barking is customer arrived to the system. He sees that the queue length is more. There is a much more waiting time in the system, and therefore he do not join the queue. Such behavior of customer is known as a barking. Now we will discuss another customer behavior, that is known as reneging. In reneging, what happened? Customer joined the queue like that. A customer joined the queue, but he looked at it will consume more time in waiting, and without receiving the service, customer left the queue and exit from the system, and this customer will come forward. So such behavior of customer is known as a reneging. Reneging means customer joined the system, but in anticipation of longer waiting time, he decided to leave the queue without getting the service. That is known as reneging. Reneging behavior of the customer. So clear, mainly there are four types of customer behavior. Bulk arrival, that is arrival of the customer in bulk. Jockeying, that is jump of customer from one queue to another queue in anticipation of lower waiting time. Barking means customer look at the queue length appears very large and he do not join the queue. Such behavior is known as the barking. And reneging means customer join the queue, but in anticipation of longer waiting time, customer leaves the queue without taking service is known as reneging. Now let's discuss various components of queuing. So now let's discuss various components of the queue. Let's take one simple queue. There are two servers and here are the customers. And somewhere here is the outgoing customers who are taking the service. So entire system is known as queue system. Here are the customer and here are the server. So let's start with queue system. The main component of the queue is first server. Now, server means a person, a system who is providing the service to the customers. It might be one or multiple. Server might be one or multiple. Second component is customer who require the service. It might be a limited or infinite. So you can say it is finite or infinite. It might be finite or infinite. For example, for any interview, let's say interview of mechanical engineering students, so the source is limited to mechanical engineering students and source is limited to the candidate to whom company has sent the call letter. So in such case source is finite, but in many cases the source is infinite. Third is service rate and fourth is customer arrival rate. Queuing theory is a probabilistic theory and so it follows a Poisson distribution. Poisson distribution and the time between two events follow exponential distributions in Poisson process. Exponential distributions. So service rate and customer arrival rate follow Poisson distribution and time between two events that follow the exponential distribution. Fifth is facility. That facility is a server, that is a number of servers, how many servers are in the system. Sixth is discipline. Discipline of customer arrival, in which fashion customer is arriving in the system. Say for example, the most general discipline is first come, first serve. First come, first serve. The customer who come first, he serve first, and it is the most common discipline observed in railway reservation, banking counter or any other places. Another discipline is last come first serve. It is rare. For example, when we are putting the goods in a warehouse, the first goods, say for example, it's a warehouse. Here is the entry of the warehouse. A forklift operator puts the first goods over here, then second, then third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, and 12th. There are different goods put in the warehouse. It's the first. So when he is taking the goods out, the last goods which is put first is taken. And so it is last come but first out, and the first is taken last. So it's a last come first serve system. Another discipline is at random discipline. Another is at priority discipline. Like in medical emergency, the emergency cases are taken on priority basis. So it is a priority discipline. So this is a discipline, how customers are approaching the system and being served by the system. So there are mainly 6 components of queue. Server, it might be one or multi. Customer, the source is finite or infinite. Service rate and customer arrival rate. Service rate follow Poisson distribution, and customer arrival rate follow Poisson distribution or exponential distribution. That is a time distribution of time between 2 events of Poisson process. Then facility, it's a number of servers. And discipline might be first come first serve, last come first serve. General discipline, that is first come first serve. Then random discipline, where the customers are approaching to the system in random and they are being served in random. And priority discipline, where the emergency, like in example of hospitals, emergency cases are taken up on a priority basis. So this is entire queue system.